Now that we know the basic terminology associated with sets, let's take a look at the types of sets. We'll start with equal sets. Two sets are equal if they have the exact same elements in them. Now, to show this, let's take two Venn diagrams to show sets A and B right here. These two sets would be equal if they have the exact same elements in them, like 1, 2, and 3 in A and 1, 2, and 3 in B. Though different sets, they have the same elements, so they are considered equal. There are also other ways to compare sets. One of these ways is a subset of another set, which is denoted by this sign. For example, take sets P and Q, with the Venn diagram shown over here. P would be a subset of Q if every element of P is also an element of Q. So let's give these sets elements. As you can see here, P has the elements 1, 2, and 3, while Q has the elements 1, 2, 3, and 4. Since Q has all the elements of P, 1, 2, and 3, P is a subset of set Q. In fact, even if I add 4 to P, it would still be a subset of Q, because Q still has the 4 that is in P, which means that P is a subset of Q. A type of subset, however, is the proper subset, which is denoted by this symbol. Taking the previous example of P and Q with their respective Venn diagrams and elements, P would be a proper subset of Q when Q has all the elements of P, but P and Q are not equal. What this means is that as long as P has 1, or 1 and 2, or 1, 2, and 3, it is still a proper subset of Q. But as soon as it has 4, it becomes equal to Q and is no longer a proper subset of Q, just a subset of Q. Get the difference? Therefore, once I remove 4, P becomes a proper subset of Q. Just to make sure we truly understand these types of sets, let's test our understanding with some practice problems. To answer these questions, just say whether the situation they present is sometimes, always, or never true. Number 1. When X is an element of A and A is a subset of B, X is an element of B. Pause here to answer. Now, this statement is always true, simply because for A to be a subset of B, B has to have all the elements of set A, which means that if X is an element of set A, it has to be an element of set B. There is no sometimes or never. This is always true. Number 2. When A is a proper subset of B, A is equal to B. Pause here to answer. Well, this one is never true, simply because the definition of a proper subset implies that A can never be equal to B. If it was a subset, then that could be sometimes true, but since it's a proper subset, it's never true. Number 3. When X is an element of set B and A is a subset of B, then X is an element of A. Pause here to answer. This one is sometimes true, and it can be better explained by drawing it out. So let's draw Venn diagrams for set A in set B. Now, we know that A is a subset of B, so let's give A elements 1, 2, and 3, and B elements 1, 2, 3, and 4. Now, of course, B could have elements 1, 2, and 3, and it would still be a subset, but for demonstration purposes, I'm adding a 4 there. Now, since X is an element of B, it could be 1, 2, or 3, in which case it would be an element of set A as well, because A has 1, 2, and 3. But what about the case where X is the element 4 right here? A does not have that element, which means that in that case, X would not be an element of A, which would make it not true. However, since previously I talked about it could be true if it was 1, 2, and 3, there are cases in which it could be true or false. Therefore, this statement is sometimes true.